So in this video, I'm going to recap both probability distributions and expected value, and we're going to do a couple of simple examples to kind of illustrate the concepts. So the first thing we'll talk about is probability distributions, and really all these are is just a measure of the probability of different outcomes occurring, and it can be expressed as both a table or a graph form. So the first example I'm going to talk us through in terms of creating a probability distribution is we're going to have two coins that we're going to flip, and we're going to measure the total number of heads, okay, between those two coins. So we need to figure out what different outcomes we have. So the first outcome might be if we flip these two coins, both of them end up being tails, in which case we're going to have a total of 0 heads, so that is one outcome. The next example might be, say, we flip these coins and one of them ends up tails and one of them ends up as heads. Okay, so between those two, we're going to have a total of 1 head, so that would be another outcome. The last possibility is that when we flip both of these coins, they both end up being heads. So then we're going to have a total of 2 heads between them. So to put this into a probability distribution, that's going to relate to the first column here. So X, this is the different outcomes that we're going to have. So we said one outcome was that we had 0 heads. The next one was that we had 1 head, and the last possibility was that we had 2 heads. So left column is just going to list all the different outcomes that we could possibly have. The second column is where the probabilities come in. So this is measuring the probability of each outcome occurring. So I'm not going to go into detail of how we get these out, that will be in a future video. But what we can say is that for the outcome of 0 heads, we have a probability of 0.25 for that happening. So that's like 25%. For the next outcome, which is where we have 1 head occurring, we have a probability of 0.5 or 50%. And for the last outcome, which is we have 2 heads occurring, then the probability of that is 0.25. Okay, so this here is our probability distribution expressed in a table format. Now, one thing just to be aware of is when you're constructing these tables is that you need to make sure that the total of all the probabilities, so we can write that as the sum of P of X, these all have to add up to a total of 1. Okay, if that doesn't occur, then you've got a problem somewhere in your table. Okay, so just be aware of that. All right, so let's do a second example, which is where we're going to look for the number rolled on a standard 6-sided dice. Okay. We have a dice, each side is labelled 1 to 6, so when we roll that dice, the different outcomes that we can have, which is what we're putting in this first column for X, okay, we can roll a 1, we can roll a 2, 3, 4, 5, 6, okay, so that's our different outcomes. So the second column needs to be the probability of those outcomes. Right, and I've already filled it in for you, but this one's pretty straightforward. If we assume we have a normal dice, then there should be an equal chance of each number being rolled, which is equal to 1 divided by 6. Okay, that's the same in decimal as 0.167, and I've already filled it in for us. So the outcome of rolling a 1 has a probability of 0.167. The probability of rolling a 2 is the outcome of rolling a 2 has a probability of 0.167, and so on. Each of them has the same one. So again, this is our probability distribution expressed in a table form, and just remember this still needs to be true. So if you sum up all the values in your probability column, they need to be equal to 1. If they're not, then you've got a problem. Alright, so that's pretty much it in terms of writing it out in a table form. However, if you want, you can convert your table into a graph. And I'm not going to go through the details of that in this particular video, but just be aware that it is possible for now. So if we go through this first example, the probability, the outcomes are 0, 1, and 2. And that's what goes on the horizontal axis, and then the probabilities here are what are graphed on the y-axis. So you can read off that the 0 heads outcome has a probability of 0.25, 1 head is 0.5, and 2 heads is 0.25 again. Same thing with this one here. You want to put your outcomes on the x-axis and the probability of those outcomes, on the y-axis. Alright, so that's pretty much it in terms of probability distributions, and there will be some further examples in future videos that you can look at. So the next thing that we are going to talk about is expected value. So that's here. So the expected value is just the average outcome that you expect from your probability distribution over a large number of trials. So you can express your expected value as either mu or EX. Okay, these are both the same thing. And this is the symbolic representation of how you calculate it. So I equals 1 to n, so that's like counting up through each of your different outcomes. So n is the total number of outcomes. Alright, and what we're going to take is xi. So this is the value of your outcome. And we get multiplied by the probability of that outcome. So let's do it as an example so you can kind of see this in action. So we'll start with the number of heads obtained when flipping 2 coins. So if we write out our equation, it was that either mu or EX, it doesn't matter which way you express it, it's equal to the sum of x times the probability of x. So writing this out, so we'll start with I is equal to 1, which is basically your first outcome. So the outcome is 0, which is xi. And we need to multiply it by the probability of that outcome, which is 0.25. And we're summing these all together, that's what that sigma symbol means. So we put in a plus, and then I is equal to 2, or the second outcome. So the second outcome is this line here. So we've got 1 for x, and the probability of x is 0.5. So last one, because we've only got 3 possible outcomes, plus. So 2 is the value for x, and the probability of it is 0.25. So if you type all of that into a calculator, you end up with the answer of 1. So what this is telling you is that on average, you can expect to flip 1 head when you have your 2 coins. Okay? So if we now do the same thing for this other example, I might come over here and do it. So we can express our expected value as either mu or EX, and it's equal to the sum of each outcome multiplied by that outcome's probability. So going through and filling this out, so we'll start with the first one and multiply it by its own probability. And then it's a sum, so we add together and we go for the next one. So it's going to be 2 times 0.167. The next one's going to be 3 times 0.167. Next one is 4 times 0.167. Might come up to the next line. So the next one, 5 times 0.167, and finally 6 times 0.167. So if you type all of that into a calculator, you get out the answer of 3.5. So what this is telling you is on average, you can expect to roll 3.5. Okay, so it kind of sits in the middle between 3 and 4. So that's all there is for this recap video. Please refer to the following examples if you want some more detailed examples of what to do with these concepts. Otherwise, see you in another video.